How do a sniffer dog and a detective help me find more effective treatments for ovarian cancer? Every year, around 360 women in Ireland are diagnosed with ovarian cancer. That is one woman nearly every single day who gets this diagnosis. Unfortunately, ovarian cancer is still a poor prognosis cancer, which means that every year, nearly 270 women will lose their lives due to this disease. This is where my project comes in. I'm trying to find more effective, kinder treatments for ovarian cancer by combining existing targeted therapies. Let's imagine this is an ovarian cancer tumour. Currently, ovarian cancer is mainly treated with chemotherapy. While chemotherapy is very good at killing cancer cells, unfortunately, it can't really distinguish between cancer cells and healthy cells, which leads to severe side effects for patients. On the other hand, there are newer targeted therapies that can distinguish between cancer cells and healthy cells, which leads to a more precise approach to cancer treatment with less side effects for patients. Examples for targeted therapies are ADCs and PARP inhibitors that I will explain to you in this presentation. Let's imagine these are cells that we have in our body. There's a lot of different healthy cells, and then in this case, unfortunately, there are some angry-looking cancer cells. These cancer cells are a bit like a gang of criminals that's trying to take over the body. To get rid of those criminals, we need a bit of help. In real life, this help would be chemotherapy. In this analogy, it's going to be an armed detective. This detective, like chemotherapy, is very good at eliminating cancer cells. But unfortunately, she's not very good at telling cancer cells and healthy cells apart, which leads to a lot of collateral damage or side effects for patients. Because that situation isn't entirely ideal, we have to give a detective a bit of help. This help is going to be a little sniffing dog. This sniffing dog can identify the cancer cells and tell our detective where to go and which cells to eliminate. In real life, this would be an antibody drug conjugate, where the sniffing dog is the antibody that brings the detective or the chemotherapy to the cancer cells specifically. After all these explanations, what do I actually do in the lab? I work with ovarian cancer cells that I grow in cell culture flasks. That's basically just little plastic bottles like the one here that those ovarian cancer cells can grow in. I grow them so I can do all kinds of different experiments with them. For example, to find out how they respond to different treatments. Let's say this is an ovarian cancer cell. It has a lot of a protein that's called TROP2 on its surface. In this case, that's all of these little bones on the cancer cell, because when I treat this cancer cell with my ADC, the sniffing dog, or the antibody, is attracted to the bone, or the protein, on the cancer cell's surface, and then it brings the detective to the cancer cell. The detective, or the chemotherapy, can then get inside of the cancer cell and destroy the cancer cell's DNA. DNA is basically the blueprint that a cancer cell would need to survive and grow. So without that DNA, the cancer cell would eventually die. Cancer cells are quite smart, so they're going to try and escape our detective by repairing their DNA and returning to their natural state. I'm going to try to keep them from doing that, so I'm adding a second type of drug that's called a PARP inhibitor. PARP inhibitors keep cancer cells from repairing their DNA. So they basically act as a roadblock that keeps those cancer cells from escaping our detective and forces them to stay with their broken DNA. This eventually forces the cancer cell to die. So far, I've seen in the lab that this approach works very well for killing all different kinds of ovarian cancer cells, even those that don't respond very well to either of those treatments alone, so to either the PARP inhibitor or the ADC. That's very exciting because it could mean that this treatment can in the future help to treat a very diverse population of patients and help a lot of people. I'm also hoping that this treatment could help treat patients whose tumours have become resistant to PARP inhibitors to give those patients a new treatment option. In conclusion, I'm working on combining a type of targeted anti-cancer drug that's called an ADC and that destroys the cancer cell's DNA with another type of targeted drug that's called a PARP inhibitor and keeps cancer cells from repairing their DNA. With this combination, I'm overloading cancer cells with DNA damage and ultimately force them to die. Because both of the drugs that I'm working with are targeted therapies, I'm hoping to find a kinder treatment option for ovarian cancer patients with less side effects. Ultimately, I'm trying to find a form of optimized cancer treatment to help make more survivors from ovarian cancer.